and I am sharing my screen. Okay, and everybody can see it. Cool. So welcome everyone. This is understanding the Azure Data Platform options, and data platform is a kind of meaningless marketing term that Microsoft uses. Don't worry, we'll define it later. But as it is, it's all the options you have to run, whether it's SQL Server or other kinds of databases in Azure. One of the things I see a lot is a lot of this comes from kind of conflicting marketing messages, because different teams own different products in Microsoft, and different teams have different goals to sell their products. So there's crossover in sales. And if you've ever worked in a big company, you might understand how organizations can be disconnected within that company. And Microsoft is just like that. So the inspiration for this presentation came to me from two things. One time I had a Microsoft salesperson trying to sell a customer of mine who's a big data warehouse organization. That means they have like terabytes of data, and they do these big range queries all the time. So they're reading a lot of that data. They try to sell them on Cosmos DB, which is something that was really optimized for fast reading of data. And I saw that happen at my customer, and I saw that happen at another customer, another large customer. So I wanted to try to kind of separate the sales messaging from what really works. And then the other reason why I put this presentation together, and I was supposed to do a different version of this at SQL Bits, was that last year I was working the SQL Server booth at Microsoft Ignite, which is the big Microsoft conference, and they recruit a couple of us MVPs to help at the booth and answer questions from attendees and stuff. And I think I was asked over the course of like 3 days about 200 times, can you explain to me the difference between Azure SQL Database and Azure Managed Instance? So between those two things, it became a ripe source of questions, and I thought it would be good to put together a pretty basic presentation to talk about the differences between the platforms. So like Anthony mentioned, I'm a Microsoft Data Platform MVP. Hang on, I just need to find my mouse. I've been doing this for a long time. I work at Denny Cherry & Associates Consulting. You can find me at JDantons on Twitter. So if you have any questions, I'll have my contact info up again at the end. But if you have any questions after this presentation, feel free to hit me up on Twitter. I'll happy to answer them. I also blog at joeydanhoney.com, and I write a column monthly for Redmond Mag called Joanne SQL Server, and that's at redmondmag.com. So this is just a map, and this is not a comprehensive map of some of the services that are in Azure. This is a lot of the services that are in Azure, admittedly. But when we talk about the cloud, we talk about lots and lots of different services, and it can be really, really overwhelming. I'm pretty good at this stuff, and I'm an Azure certified architect, or whatever we call that certification, and like once a week there's some new service I learned about that cropped up. Just last week I was working on a project with some folks, and I learned about a new service I had never heard of, and it turned out it existed for like 3 years. So just one thing to note, no matter what you are or who you are, you're never going to know all of Azure. The important things are to kind of know things at a high level, and that's why I like this slide, because it kind of breaks some things down. If we look on the bottom, we think about data center infrastructure. The cloud is not magic, to quote Argenis. It's just somebody else's computer. In the case of Azure, it's somebody else's tens of thousands, possibly millions of probably millions of computers. The cloud runs on standard hardware. It's not vendor purchase. Microsoft probably has it custom made, but it runs on Intel and AMD chips. Or NVIDIA graphics cards, because there are some GPU workloads. You have memory, and it's, for the most part, all built on a virtual platform. So it's similar in nature to VMware in the fundamental infrastructure. Azure runs on something called Service Fabric, which you can also develop apps against, but the underlying infrastructure is known as Service Fabric, and that's what runs Azure and makes all the magic happen. And we have infrastructure services here. We're going to talk about the difference between infrastructure as a service and platform as a service in detail in a couple of slides. But the important thing to note is that everything runs on the core infrastructure services. So even though you deploy an Azure SQL database, and you just get that database and you don't have to manage the OS or the availability or anything like that, Microsoft manages that OS for you, and that runs in a virtual machine, and that uses Azure storage. So all the services you would use if you're building a VM or what platform as a service and software as a service offerings are built upon. And we can kind of break these down, and this is kind of what I mean about understanding things at a high level. So we see we have data, and we have SQL database, and this slide's a little old, so it's a SQL data warehouse. We call SQL data warehouse Azure Synapse Analytics now. We see analytics and IoT. So we have HD Insight, which is the Hadoop offering from Microsoft. We see machine learning and data factory and some of those other solutions. We see integration. So these are services that help your app run. Web and mobile. So web apps are effectively web apps, IaaS as a service almost, or web server as a service. And then we have like ancillary features off to the side that help us run things like Azure Active Directory, automation, and Key Vault. And all of those things together work to bring you kind of an infrastructure. And I wanted to do one like quick demo. I'm not going to go too deep, but let me make this a little bit bigger. Sorry about that. So this is the Azure portal. If you haven't been here, there are apps that you can use to manage this as well. This is my subscription for my MVP. And I have a few things in it. So the sidebar will show us more things. So I can go home, which is where I am, or I can see all of my resources. And this is everything that I have in my subscription. So I have various services. I have a domain controller. I have some network things, and I'm going to drill into a VM that I have that's running SQL Server.
Hey, Joey, can you go a little bit bigger on that, please?
Yeah, no problem.
Cool, thank you.
And here we can see this machine's been really quiet today, but if I look at it over 7 days, I know I did some stuff. That's why I chose this resource. I can see that this was the day I did a lot of stuff, because I can see my network usage was up. I can see my disk operations were up here. And these are all metrics that are captured by the portal. The way this works is inside of my virtual machine, Azure puts an agent on that VM. So when my VM reports back, I get all this information. Likewise, I have an Azure SQL database here. And I'm also going to have metrics about that, because the Azure service is actually surfacing this information. So this database got resized. That's why I don't think we're seeing any activity. But were there activity, I would see that activity show up here. So one of the benefits you get of going to the cloud is that you have some built-in level of monitoring and built-in options that you might not otherwise have. So this is a slide I always like to joke. This is probably the thing that changes the most frequently in Azure, is that Microsoft adds regions. Every time I do a presentation on Azure and I have this slide, I go to Azure and I get a screenshot of the slide, or I take a screenshot of this image and I paste it into the slide, because they're always adding new regions. There's not much to say here, but there's a couple of things I want you to note about regions. Regions are always deployed in pairs, with the exception of Brazil South. And regions are deployed into geographies, and that's where we get the pair. You'll notice, with the exception of Brazil, every country that has one region has at least two. And that's because those regions are paired together for disaster recovery purposes. Microsoft has thought of this ahead of time. So you can easily move your data to the region best suited for you. This also helps you put data near your customers to reduce latency of your application. And the other thing to note is that all regions can be priced differently. There's a website called azureprice.net that will allow you to see the pricing of VMs in various regions. And I've seen up to 30 and 40% differences in prices for the same VMs across regions. And that's an interesting thing to note. It's not always going to work for your production application to put your servers in, say, central India, But if you're just doing development and you're doing development exclusively in the cloud, that can save you a good deal of money. So one of the other things we talk about with cloud is software as a service, infrastructure as a service, platform as a service, and this is all confusing. So this is a build slide. I'll just build it out. The easiest way I like to talk about this is the Spectre and Meltdown patches that happened a couple of years ago. In January of 2018, Intel discovered this vulnerability in their CPUs, which basically meant every computer and every program in the world had to be patched. So if you were on premises, you had to patch the firmware on your servers. If you were running a hypervisor like VMware or Hyper-V, you had to patch that hypervisor. You then had to patch your operating system, and then potentially you had to patch other programs like SQL Server. So you would have to patch all the way from the ground up. If you're running infrastructure as a service in Azure, infrastructure as a service being VMs and storage and networking, you got an email from Microsoft on the morning after the patch was announced saying, or the vulnerability was announced saying, we patched the underlying infrastructure that your VMs ran on, and we rebooted them last night. You still, please install these patches to your operating system and any other software. So in that case, if you had a SQL Server running in an Azure VM, you had to patch your OS and SQL Server. Azure patched the underlying virtualization and infrastructure for you. If you had an Azure SQL database, which is a database as a service offering, so platform as a service, you didn't have to do anything. Microsoft didn't, I don't even think they sent an email. There was probably a brief outage, but everything underneath was patched for you. So like with Azure SQL database or Synapse Analytics, all you manage is security, and then your data and structure. You no longer patch SQL Server. You have options around the backups are done for you. A lot of the regular tasks that a DBA might perform are executed by the Cloud Fabric, which means you get to spend time tuning queries and optimizing data structures. Finally, in software as a service, this is like Office 365 or Salesforce. These are just software programs you can consume, and everything's in the cloud. Really, the only thing you manage is the security and, to an extent, some configuration options that you may have. So what the heck is the Azure Data Platform, other than a fuzzy marketing term that doesn't really mean anything? Hint, it's a fuzzy marketing term that doesn't really mean anything. But here's what it consumes or covers. SQL Server is part of this. So always, even though SQL Server doesn't have to run in Azure, it's considered part of the Azure Data Platform because it's really a foundational element. We also have Azure SQL Database, Azure SQL Database Managed Instance, which we'll talk about the differences between, Azure Cosmos DB and Synapse Analytics, which we'll also talk about in this session. Azure Data Lake and HD Insight we won't talk about, but those are both Hadoop related offerings. HD Insight is Hadoop as a service, and if you're not familiar with Hadoop, Hadoop is this distributed data analytics open source system. Data Lake is really just a storage element, so it's a storage layer that's got HDFS, which is the file system Hadoop runs as, laid on top of it. So it's pretty similar to Hadoop. It's just there's no compute associated with Data Lake. So you need to get your compute from somewhere else, whether it be Synapse or something else. We also have Azure Data Factory, which is an ETL tool in the cloud. Data Catalog and Event Hubs are all part of this. Integration services, of course, if you're on-prem. And then the machine learning services, and then other services like cognitive services, Bot Framework, and Power BI are all considered under Data Platform. Realistically, this is an organizational thing at Microsoft, but the common element between all these services is they store and analyze data. So let's talk about SQL. And Azure or SQL Server on Azure virtual machines. This is a very common option for a lot of reasons. First of all, Azure SQL and Azure SQL Database and Managed Instance always run on the latest version of SQL Server, which means right now they're running on kind of sort of SQL Server 2019, but maybe not. So it's probably a couple of versions ahead where we are in terms of SQL 2019. Microsoft keeps those versions always at the latest. So if you have a vendor who will only support their terrible app on SQL Server 2008 and Windows Server 2003, you should probably find a new vendor. But in the meantime, your only option would be to run on a virtual machine, because you're not going to get SQL 2008 in Azure SQL Database. You do, however, have the option of that compatibility level, but we know software vendors and how terrible they are. The other reason to run SQL Server on a virtual machine is if you're running some other services alongside of the database engine, whether it be SQL Server integration services or machine learning with R and Python, or even SSRS reporting services. Those things are separate, so there's no reporting services as a service available. So what you can do is you can stack stuff and to an extent get more value out of your SQL Server licensing by doing that. So that's SQL Server on virtual machines. It's pretty straightforward. It's just SQL Server running in a VM. The hard part's all the other stuff you have to do in Azure, like making the networks, configuring the storage, but that's a different presentation for a different time. But just foundationally, you can think of it just as SQL Server in a VM. Azure SQL Managed Instance is kind of similar to that in the fact that it's just SQL Server, and it's got about probably 97, 98% feature compatibility with regular on-premises SQL Server. And the reason why we have SQL Managed Instance and Azure SQL Database is Azure SQL Database kind of evolved. It was one of the first Azure services. I think it was the second service dating all the way back to 2009. And I've been working with it for that long, which makes me feel really old that I have a decade of experience with Azure SQL Database. We've also changed the name of the product. It was originally called SQL Azure. And originally, it was really kind of a terrible product. Your databases could only be 5 gigabytes in size. And Microsoft originally used transactional replication for high availability, which, if you're not familiar with transactional replication, it doesn't support a lot of features that SQL Server, that you would want in SQL Server. Like, for instance, every table has to have a primary key and a clustered index. So it was really kind of bad at first. Around SQL 2012 or around 2012, Microsoft made a lot of enhancements to Azure SQL Database, and it became a very viable product. But the whole model around Azure SQL Database is a single database. So you have a database. Well, excuse me. This is where this gets fun and complicated. You have a single database for a pool of databases, but even in that pool of databases, you can't issue cross-database queries. So where you're joining data from one database to data in another, that's kind of a no-go in Azure SQL Database. There's a workaround to do it, but the performance is really unpredictable. And in addition, it's on shared infrastructure. So one of the other limitations that is there is that you can't run CLR. So if you have any code, which is common language runtime, if you have any code that uses CLR, assemblies, functions, stored procedures, that can't be run in Azure SQL Database. There's also no SQL agent. So what I like to say is that Azure SQL Database is probably the best fit for applications that are born in the cloud. So if you're building a new application from scratch and you need a relational database, use Azure SQL Database. If you're migrating an application from an on-premises SQL server, you're probably a better fit using an Azure SQL Managed Instance because it has more in common. The other thing with Azure SQL Database is you can't restore to it. You can restore your databases into Azure SQL Managed Instance. You also can't take backups in Azure SQL DB. And Azure SQL Azure Managed Instance, backups are taken for you by the service, but you can take copy-only backups, which is a backup that doesn't update the differential bitmap. So that's kind of where those options fit together. You can also use CLR, like I mentioned. You can do cross database queries, which is usually the biggest issue that people hit. Azure SQL managed instance is hard to test and deploy in your test environment. So one of the things that I'm going to add some additional resources for you at the end of this presentation. What I would recommend you do is spin up an Azure environment, but you're probably not going to be able to spin up a managed instance because they're relatively expensive and they take on, they're right now, especially because Microsoft has restricted some things to free accounts, they're not going to be available. But if you're in an enterprise and you want to test something and you want to spend some of your boss's budget, it's a pretty cool solution. Realistically, it's just SQL Server running as a managed service. So all the benefits you get of platform as a service, which the main things are backup. The main benefits you get with platform as a service are automatic backups, built-in high availability because the solutions are highly available by default, and patching and install. So you never have to patch the OS or install SQL Server or anything. That's all done for you. So with SQL Server, the benefits of why you want to run on a VM is that the main reason I see with customers is that they want to migrate to the cloud as fast as possible, and they want to replicate their on-prem environment. So they're not trying to rebuild their apps because even moving to managed instance could require some level of re-engineering of your application, less than if you were moving it to Azure SQL database, but not as much as just moving to a VM. The downside to doing that kind of a migration is it tends to be a little bit more expensive because larger VMs tend to also be expensive. But the key features here, you control the SQL Server and OS versions. You can run on Windows, Linux, or containers. You have file stream, which also is not an option in managed instance. Distributed transaction coordinator, which is limited in managed instance. In the simple recovery model, which is not an option in any of the managed services. You can also run SQL Server analysis services, reporting services, and SQL Server integration services. In terms of running SQL Server in Azure, there's not a big deal. The biggest underlying thing that you have to configure correctly is your storage. And recently, Microsoft has added functionality into the Azure portal that will configure your storage for you. So you can just supply it a number of IOPS and the SQL Server template will configure your underlying storage for you, which is really kind of cool. So the other two here are Azure SQL Managed Instance. And like I said, we have the vast majority of the SQL Server surface area, built-in virtual network support. So by default, when you create a managed instance, the only way you can connect to it is from another VM on the network, the virtual network that it's on. It does not have a public endpoint by default. This is a fully managed service. So that's also kind of cool. And you have this option to have an instance pool. And an instance pool is just simply kind of a way you can segregate workloads. I'm going to talk about an elastic pool in a second for SQL DB. That's a little bit different. So an instance pool, you buy managed instance by the virtual core. And the minimum you can buy is 4. And I believe to host instance pools, you have to buy 8. And you can split that up. You can split up those 8 cores in 4x4, and the cost is the same. So the only reason why you want to do this is if you want to split some of your workloads between instances. Azure SQL Database has a couple of other options that we're going to talk about. Remember how I was saying how bad Azure SQL Database was when it first started? I think the size limit was 1 in 5. There were 2 tiers, and I think the size limits were 1 in 5 gigabytes. It's a little bit different now. We have this deployment option called Hyperscale that will allow us to go up to 100 terabytes. So that's really kind of cool. And Microsoft has really done a really interesting architecture with the way that's scaled out. I wrote a column at Redmond last year. If you want to learn more about that, I recommend reading it. There's also a really cool technical white paper that Microsoft read about how they deployed it. And it's kind of a unique way to do things in the cloud because you can't infinitely scale up, you have to scale out. And that's exactly what they did. Azure SQL Database also has a serverless option. I like to call this serverless option auto pause and auto scale. Effectively, what will happen is if your connections are idle for a long time, your database will pause. You'll get an error the next time you log into it, but the database will subsequently restart after that error. So that's really something that's kind of cool for dev and test environments, because it can greatly reduce your cost. The one thing you want to watch with serverless is that it is more expensive per minute than normal Azure SQL database. So because of that, it's not something you want to run. You want to run a workload that runs 24/7 because you'll end up spending more money on it. Private link support. So private link is a way you can connect privately into your Azure SQL database. By default, you connect over a public IP address, which means your connections go over the public internet. They're encrypted, but you're still hitting a public IP address. Private link allows you to come in through Azure. And if you're even in a hybrid environment and you're on-prem, as long as those two networks are joined together with a gateway, you can come in fully privately, which addresses a lot of security fears. So fully managed service, and there's a couple of additional benefits that Azure SQL Database has that no other service, especially around SQL Server, has, is that you can manage your indexes to an extent for you. So it will add and remove indexes as it sees fit. And the way the service does this is really kind of cool. It deploys a second copy of your database and also captures your traffic and measures the performance improvement of the adding and removed indexes. So that's kind of a cool feature. There's also some security intelligence that's added. The last thing about Azure SQL Database is that we have elastic pools. And when we think of a single database, you need to think of a SQL Server instance that's simply hosting one user database. When we think of an elastic pool, think of a SQL Server instance that's hosting multiple databases. That means those databases share resources with each other, and the pool shares a common set of resources. Azure Synapse Analytics. So I don't know how many of you have worked with Microsoft for a long time, but you might know that Microsoft likes to change the name of things, and they're not really consistent with how they do it. So Azure Synapse Analytics used to be called Azure SQL Data Warehouse, and possibly SQL Data Warehouse before that. I don't remember the full etymology of the name change, but at Ignite they announced Synapse Analytics, which is SQL Data Warehouse plus a lot of other stuff that they've added. But I'm going to kind of focus on the SQL Data Warehouse part and what it is. So Synapse Analytics is what's known as a massively parallel processing system. So SQL Server is what we call a symmetric multiprocessing system. Multiple CPUs are used to compute individual processes, but all CPUs share the same memory and disk and network controllers. So if we want to increase the size of an SNP system, we buy a bigger server. With massively parallel processing, it uses separate CPUs running in parallel, but each CPU has its own memory and disk. So this is a scale-out model, and segments communicate using a high-speed network between nodes. So this is a really good design for a data warehouse because you're not updating it that frequently. The challenge you have, and typically with data warehouse workloads, you can partition your data efficiently because frequently it can be partitioned by date or some sort of range like that. So queries are very efficient because one of the problems with massively parallel computing is that you don't want a lot of data moving across your nodes. And I probably should have had a graphic for this, but if we think about that we have 10 nodes or 100 nodes, and we're reading a set of values from each one, we want to combine those values in our control node, which is how this works. There's a control node, but we don't want to have to have each node reach out to the other nodes, or east-west traffic, as we would call it, because that's very expensive. And where we can get into these scenarios, and this once again is just kind of a sales thing that I've seen happen, or customers think they have, you know, a massive 500 gig database, which is big to some people. I had a customer who I remember this well. They're like, we need your help migrating this really, really big database. And I was like, so how many terabytes? And he's like, it's 60 gig. And I was like, oh, okay. That's not a good fit. The other things that are not a good fit for your data warehouse, OLTP workloads. So OLTP workloads are the opposite of data warehouse workloads. We like to think of data warehouse workloads as OLAP, or online analytical processing. They're mostly read workloads, and when we do insert or update data, we do it in bulk. And that's one of the places where we get more efficiency from massively parallel systems, because that bulk insert is very efficient. High frequency of read and writes and updates would not be a very efficient model in a massively parallel system, because it would require us to do a lot of east-west traffic, and it's just not a great thing. Also, we're not optimized for selecting a single record. Typically, the kind of questions you would ask of a data warehouse are, what were our sales for the last quarter by product? So aggregate all the sales, give me the sum, and then join to the product dimension and sort that out. That's a really efficient use case of a data warehouse. Giving me a customer name where a customer ID is equal to 112 is not. And one of the reasons for that is data warehouse, or Synapse Analytics, relies heavily on a feature of SQL Server called column store indexes, which themselves are not well suited for reading a single row. Likewise, high volumes of single row inserts, that's not an efficient pattern for that paradigm. And then data preparation, so things that have row by row processing or incompatible formats like XML. Row by row processing isn't a great model for databases in general, but it's especially not for a massively parallel system. What workloads are suitable for Synapse Analytics? Analytics, so where you store large volumes of data, where you want to shape, model, and transform, perform query analysis across large data sets. And we say large data sets, I typically mean at least a terabyte or more, if not more, and all using basic SQL constructs, because our SQL is a little bit more limited in Synapse Analytics and Data Warehouse. It's not the full same T-SQL footprint. Typically, what I'll tell you is if you have a workload that requires a massively parallel system like this, you'll know it, and you'll probably have 5 or 6 terabytes of data at least. And you may even be on a platform like Teradata or Exadata or any of those popular data warehouse appliances. The other one I'm forgetting right now. So this isn't something you're going to build a small database in. One kind of thing that Synapse Analytics has is you can pause your compute. So similar to serverless, it's a little bit different though, because you're in control of it. But similar to serverless, where it will pause, you can pause compute, which means you can't query anything, and you're only paying for storage. The thing about that makes this a little bit more friendly, if you want to play with it and get some experience on it, you can do that in kind of a cost-effective manner. So I used a Microsoft marketing slide for this because Cosmos DB is I think it's really, really cool, really, really amazing technology. But at the same time, it's got the worst case had the worst case. I think this has gotten better. But of Microsoft sales folks trying to tell people it's the best thing since sliced bread and you should use it for everything, when that is like distinctly not the case. This is a fully managed, globally distributed database service built to guarantee extremely low latency and massive scale for modern apps. Doesn't that sound like we should use it for everything? Because that's amazing. I want that. Good marketing goes a long way. Let's talk about what Cosmos really is. So everything they said is somewhat truthful. Cosmos DB supports all of those NoSQL databases your developers told you are really cool. And no offense to any developers on the line, they really are cool for some workloads. So we see up top, we see SQL, we see Cassandra. Cassandra is a column family database that's really good for things like product catalogs. MongoDB is a JSON database that's generally terrible, but The Cosmos implementation of it is just the API and its own database that Microsoft used to call Document DB. And that stores JSON documents and allows you to easily read and write from JSON documents. It also includes a table API, which is used for key value, which is kind of a good, things that are a timestamp and then a series of records. It also uses Gremlin, and Gremlin's a graph engine. And if you're not familiar with graph databases, they consist of nodes and edges, and they're used to define relationships. So the common thing we like to talk about is friend of a friend scenarios. So if you think about LinkedIn or Facebook and how they recommend the people that you're friends with, those are all graph scenarios. So any one of these services are really good fits for some database, but where this isn't a good fit is for the person with 5 or 6 terabytes of data. The other thing about Cosmos is it's relatively expensive compared to, say, for example, Azure SQL Database. They've worked to improve that, but the minimum cost is still pretty high, so it's a little hard to get started on. It does have some really cool features, though. You can scale out storage and throughput. There's a guaranteed low latency. You can choose your consistency model. So one of the things us database folks make fun of about NoSQL databases is that they're eventually consistent. So that's not something you'd want to use for, say, your bank balance, because you wouldn't want to deposit a check and not have it show up for 3 hours. That would scare me. But Cosmos gives us a tunable consistency model. And the reason why we might want that is for a database that has a very high write workload. We might want to be able to apply those writes later. And some examples of that might be gaming systems where you don't have to make that write immediately to make it, but you have a high volume. So that's kind of a pretty cool thing. The other thing that really sounds cool to folks is that you can have global distribution. So you can have multi-master, which means you can write in 2 places and have conflicts resolved. There are a lot of caveats around how that works. It's one of those things that sounds really great on paper, but conflict resolution is hard, as we know. So those are some of the issues that those sorts of databases had. One of the things I do like to talk about cloud, and I'm not trying to down on Cosmos DB because I think it's a really cool service. You don't have to, if you're building an application from the ground up and you're in the cloud, you don't have to rely on a single data store for your application. In fact, you might not want to, because it concentrates all of your apps, all of your data into a single point of failure. You might have some part of your app that runs in Cosmos and a key value. You might have another part that runs in a graph database. And then you might have transactional data that you're storing in a SQL database. And you might aggregate all that data into a data warehouse. That would be kind of a very common scenario. We call that the term for that is called polyglot persistence. Is that we persist data using different flavors of things and using the most optimal data store for a given workload. So that's kind of how these pieces all fit together. So Microsoft defines some use cases for Cosmos, and I think this is kind of cool to understand. So some common use cases, one of which is IoT. And IoT devices process a lot of data quickly. So these systems are Internet of Things, as we call it. I'm sorry for not defining the acronym. But they share some patterns on how they ingest, process, and store data. They need to be able to ingest bursts of data from sensors of various locales, and they have to process and analyze streaming to get the insight from that data. So typically with like IoT data, what you're looking for is out of range values. So where you would use Cosmos would be to look for those out of range values and then do something based on that. Whether it's trigger an alert, show something in a dashboard, and then you would archive all the records into some sort of long-term data, colder data storage, maybe a data lake, maybe a data warehouse, maybe even a database if the volume's not that high. So that's really kind of that IoT use case. And what I just described to you is known as Lambda architecture. And that's where you kind of have a high-speed path and a batch path where you're storing all the data. Also, Cosmos DB is used kind of extensively in Microsoft's own e-commerce platform, like Xbox Live. You can also use it to store catalog and event sourcing data. Catalog, commonly with column family databases, which is that Cassandra API, but also sometimes with Mongo or Document DB, where you're storing JSON documents. And you can also use it for event sourcing and order pipelines. And the catalog use cases where you would store people, places, and products, or user accounts as well. Gaming is a place where this makes a lot of sense. So games produce a lot of data, and it needs to happen really quickly in a lot of cases. So modern games perform graphical processing on mobile devices and console clients, but they use the cloud to deliver customized and personalized content. So things like in-game stats, integrating with social media, high score leaderboards. They also need really low latency, so this is a good scenario for Cosmos. And then finally, web and mobile applications. So if you're a company now, you have some sort of mobile app. So these can store and query user-generated content for social media, things like chat sessions, blog posts, ratings, and comments. And often it's a free form of text. So this can be a good fit for JSON or key value. And relationships or schemas aren't well defined. So not having to do those transformations into a fixed database schema is one of the reasons why, frankly, developers like this kind of database so much. But these are the really good use cases for it. The other thing you want to note is if you're not in one of these use cases, or data patterns, as I'd like to call them, it's probably not a good fit for you. So this isn't something you want for a data warehouse. It's also probably not something you want for a financial application that's actually handling the processing of money. I would probably get some feedback on that from Microsoft, but I'd rather that happen in a relational database where I have a stronger, better, well understood consistency model. So what you kind of learned today, you should understand what the public cloud is. And I know I mostly talked about Azure. Amazon's not that different. It has a similar set of services. But if you're getting started with this, I recommend learning one cloud first. It's much easier to learn a second cloud after you've learned your first, because the concepts are very similar, but trying to learn two things at once is really complicated. So if you can grasp, Azure and you can get your head around that, when you then go into Amazon, everything will kind of click and make sense, except for the GUI, which is terrible. Know your platform options. So what we did today was kind of go through a lot of the Azure data platform options. SQL database, managed instance, SQL server, and a VM. We went through all those things. I kind of talked about use cases for each of them. SQL and a VM, moving legacy apps, SQL managed instance, modernizing, SQL DB, new app development, and understand what workloads fit and where. Don't try to put a big OLTP application that does millions of requests per second into a Azure Synapse Analytics data warehouse. That's not going to be a good fit. And remember, you can always use multiple data stores for your application. You're not limited to one machine. And kind of the cool thing about cloud is that it's very easy to add another data store. You're not bound by the fact that somebody has to install something on a server or create a new VM. You can just add that service to your subscription. So I had a couple of other slides I just wanted to kind of showcase here real quick. Next steps for learning. I'd recommend creating a trial account and playing around with Azure SQL Database. You can run an Azure SQL Database for a few dollars a month, especially with serverless. If you're not using it that much, it's very cheap. You can consider the AZ900 exam. This is Azure Fundamentals. It's a pretty broad exam, so in studying for this, you'll kind of get the idea of what the major things in Azure are. And after that, you might consider the DP300 exam, which is a new Azure Data Platform exam that's still in beta, but should be coming online in the next month or two. With that, here's my contact info. If you have any questions, feel free to email me or tweet at me. Anthony, do we have any other questions?
So I fielded most of the questions, but I do have a collection of questions that I picked up along the way if you want to go through those.
Yeah, go for it.
So you talked about compatibility mode a little bit in SQLDB, and that SQLDB, your database, is always on the latest version. Is compatibility mode a feature that's available inside of SQLDB that I can leverage to kind of get backwards a little bit if I need to?
It is. Compatibility mode is supported all the way back to 2008 in SQLDB and managed instance. So it's just like SQL Server 2019. And Microsoft will support you running on an older compatibility mode for an extended period of time. Of course, you should note that a lot of the cool new query tuning and automated features are only available in the latest compatibility mode, but you still get the benefits of being on a supported version.
So on that concept of latest version, is there a way for me to opt out of that automatic updating and latest versioning?
There is not. That's one of the perils / benefits of being on the cloud service. So I know I've heard some talk at times about there being at least control as to when you get upgrades, but as far as I know, that hasn't happened. Microsoft now patches. There's a really cool blog post from the engineering team about how they basically replace libraries in memory, so that they can patch your SQL Server in Azure without downtime. It's kind of amazing.
Yeah. So just more generally, so let's say you are migrating a system from on-prem into Azure. Like, when you work with customers, what are kind of the first things you dig into in that initial analysis when you start those kind of projects?
So I honestly don't go too deep. Like, if I'm moving just in particular to SQL Server, if I know I'm moving from a VM or a physical machine to a VM or a VM to a VM, I really only look at 3 or 4 metrics. So I look at CPU utilization and the number of CPUs, so I can get a rough idea of how many CPUs I'm going to need. I look at page life expectancy, which is how long SQL Server expects a page to live in memory. And it's a good indication of how busy the memory is on a server and how utilized it is. So if that's a very high number and it's very stable, it means the memory on the server is not getting used that much and we might be able to run with less. On the other hand, if it's like 10, you know, the memory is getting hammered. And then finally, I like to look at the IOPS that SQL Server is doing. And there's 2 ways you can do that via perfmon. And that's, there's a Windows counter called disk reads per second and disk writes per second. And then inside of SQL Server's perfmon counters, in resource governor, so if you're on SQL 2014 or higher, there are some read-write IOPS counters from inside of SQL Server. I like to look at both of those. I mean, they should match. You shouldn't have anything else on a SQL Server performing a lot of I/O, but that's something I like to look at. With that in mind, you can then build the underlying storage capacity to meet the needs of that VM, and that's kind of what that comes down to. In terms of SQL database and managed instance, I just like to look for things that are not going to work on the platform.
So, like, are there some tools that can help you make that decision on what's going to work or not?
There is. There's a tool called I believe the Database Migration Assistant or Data Migration Assistant from Microsoft that will help you migrate as well. There's like 3 tools in this space and they're highly inconsistently named. But if you search Data Migration Assistant Azure, it'll link you to the right one. And they're not even consistently named within Azure in the portal. So as we know, Microsoft is really good at naming things inconsistently.
Right, and then changing them. And those kind of tools, though, those will help us with kind of that compat mode question that we started with in latest versioning, right? That's going to help kind of highlight what's going to break.
You can even test, like you can do performance regression testing if you give it an extended events trace file. Because that ultimately, when we talk about compatibility level, there are always 2 risks when you upgrade a version of SQL Server. The first being that the upgrade's just going to fail and your binaries of SQL Server are going to be screwed up. That's a relatively low risk and it's pretty easy to remediate. You just uninstall and reinstall. The bigger risk is longer term, that changes in the way the query optimizer works in a newer version can impact your query performance. And that's a lot harder to test for because you don't run all your queries all the time. And I've seen charts from this at Microsoft where, you know, a very, very high percentage of queries improve small amounts when they improve the query optimizer, and a very, very small percentage of queries degrades large amounts in performance. So this mainly happened around SQL 2014 when Microsoft changed a feature of the query optimizer called the cardinality estimator. And a lot of people had that scenario where they had a small percentage of their queries that suddenly ran much slower. So by using compatibility mode, you can kind of ensure that performance doesn't change.
What, from a, I guess, performance standpoint, like when you move databases into Azure, what do you consider a large database, and when do you start feeling, especially like in an OLTP workload, what kind of focus in that domain? Like, what do you consider a large database, and what are some of the pain points that kind of surface when you see someone maybe do something too quickly to move that kind of workload into Azure?
So, I mean, I'd consider a large OLTP database anything over 1 terabyte. The thing I'm dealing with right now in a customer is they clearly, whoever built their systems, didn't understand how Azure storage worked. And this was the webinar I did on Monday. Azure, so the way each disk has a fixed number of IOPS in Azure, and the exception to this is Ultra SSD, which is a new offering. But if you're just using premium storage, the way you gain IOPS is by pooling multiple disks together. And typically you'd have one pool for data files and one pool for transaction logs. And you get 5,000 IOPS on a 1 terabyte disk. So if you needed 20,000 IOPS for your data files, you would make a 4 terabyte pool using storage spaces if you're on Windows, Logical Volume Manager if you're on Linux. And you do this in a way where you're effectively striping the data across those disks, so you get all those IOPS. You get the sum of the IOPS, so you'd have 20,000.
Like the old days with disk arrays.
Yeah, except it's RAID 0 to the OS. It's RAID 0. It's protected underneath. But yeah, in this case, the customer set up like, and it's set up really oddly. They have like 5 disks, and they're all set up as mount points directly on the F drive. And for example, they put TempDB on a disk that, like a 256 gig disk that only has like 1,200 IOPS, and the write latencies for TempDB are like 350 milliseconds. And if they had kind of followed best practices, or even just built the VM using the new SQL Server template, they'd be in a much better place performance-wise. So storage performance is really the big one, because it's harder and it's different.
Okay. Well, cool. I think there's one more question in there that I think we'll grab offline, but we'll let the next presenter get set up and get going. But thank you very, very much, Joey. Very insightful. Kind of gave us a big, broad view of Azure and the service offerings in the data platform universe. So I appreciate your time.
Thanks, everyone. Bye.